So with no further ado, we usually let Camp here run it. So come on over, Camp.
Thank you very much. In case you didn't know, the Bay Bridge is going to be closed in about 40 minutes, okay? So just want to get that out there. 11 years ago, some of us were lamenting the lack of robot building activity in the club, and we noticed that building activity coincided with contests. We had a line following contest, a maze busting contest, but you know, at the end of it, there were winners and losers, and you know, you didn't quite have the tape right, or you didn't, the way my maze was, you know, more wide or some, whatever. And so we knew there were a lot of robots in the club, and we didn't want to have to lug around this stage and everything. And so we were meeting at a library at the time, and so we thought, oh, let's do tabletop soccer. You know, we'll put little nets around the table and that sort of thing. It's like, no, that involves setup. And that's when it was born, the TableBot. A TableBot is a robot designed to survive, live, and play on a table or pay the price. And so, you know, how do you do tabletop soccer? You do it one step at a time in phases. And so what we came up with was phase one was going to be to build a robot just that goes from one end of the room to the other, or one end of the table to the other and back. Then phase two was to push a block off the edge of the table. And then phase three was to move the block into a shoebox mounted at the end of the table. And we've done these challenges now in the months of June, August, and October for this will be our 11th year. So without any further ado, here's one of our club bugs, BugBot. Or no, was it Club BugBot? Yeah. And we'll try to get this block into this shoebox. Hang on a second. How many TableBots are out there? Show of hands, please. 2, 3. TableBot? 4. Okay, cool. Bring the TableBots on up and let's get queued up over here if you don't mind. Where's Alan? Then again, there's the infamous phase 4, where when the robot falls off the table. That's okay, as long as it still runs when you put it back on the table. You can actually accomplish phase 4 before you accomplish phase 1, 2, and 3. Oh! Got a candidate for phase 4 here. That didn't happen at the house. Hang on a second. Come on. Oh, I'm pushing it off the edge anyways. Yay! Should do this little victory dance here. There you guys. Oh, you want more? Just gotta reposition that seat. So as you can see, this is casual with this thing. It's not really a contest, it's just a challenge. I'm losing a wheel there. Now let's see if we can do one more phase 2. Yay. Thank you. Are we having fun yet?
Yeah.
All right, very good, Marcus. Okay, who's the next TableBot here? Okay, Shiloh Curtis, and her dad, Dave. Maximus Dominguez Maximus, Duhicus Maximus. Stop me, please.
South. Yes.
While they're getting set up, if you have a TableBot that you plan to show tonight, please form a line over here so that we can keep things moving smoothly. Or at least wait until, you know, the person in front of you has done and then come up.
Tell us about it.
Okay, so this is my robot, Duhingus Maximus. He's been kind of a fixture in the Robot Club for quite a while now. He has, I'll tell you about him. He has 4 touch sensors here for sensing the table, one of them for sensing the ball here, and another IR for sensing the ball. A compass sensor for seeing which way the goal is, because we point the goal south so that the robot can turn towards the goal, which is south, and then see how close it is with the ultrasonic sensor. And we have also 2 sensor multiplexers from High-Technic, I think. Yeah. One of them is the touch sensor multiplexer that routes the 4 touch sensors into one port, and the other one is just a general sensor multiplexer that routes basically any generic sensor into one port. And that's pretty much it.
That's phase 3, folks. Twice. How many gold medals has Duhingus Maximus won over the past years?
2 gold medals, 1 silver.
That's a medal-winning robot here, ladies and gentlemen.
Included gold at the last Robo Games.
There we go, current gold medal winner. Tabletop navigation, I believe they've got it. All right, what's going on next here? All right.
Any more table bots, please come up
You need some
here.
tape? You need some tape to take this down? Looks like we've got a line follower here.
How do you, okay. So it's a very simple bot. I call it the line bot. So it has 2 servos here that are connected to wheels. That's the only movement system it has here. And for here for additional stability, it has 1 wheel. It's not connected to anything, just to help it balance out more. And on the bottom of the robot, I have 5 infrared sensors. How they work is they just send out a beam of infrared light and they pick up the return light that bounces off the surface. And the purpose of this bot, you put it on a track like this. It's a white poster board with a black electrical tape to denote where it will travel. And it can detect where the black line is and automatically follow it. And that's basically all it does. So, and I have a demonstration. Okay. So, I haven't installed a battery yet, which really sucks because I have to always have it plugged into my computer to test it, which is really lame. So, yeah. Oh, and if it ever makes it into this black box, then all 5 sensors will read black, which will make it stop. So,
What's your robot's name?
I don't have a name.
Don't have a name?
I just refer to it as the robot.
As soon as it gets a battery, it'll have a name.
Oh, I can call it line bot sometimes, I guess. But yeah.
That's not nice.
Yeah.
I'm sorry, I thought you said lane bot.
Where's our
That
next
is
tabletop?
very nice. Come again in October. All right? Have it be portable. We do this challenge meeting the months of June, August, and October. So in 2 more months, you'll have an opportunity to again show what you've created. Do we have any more TableBots out there?
We've got FloorBot queuing up. We have
Do
another
we want to do the
tabletop.
floor? Do we want to do that now?
Yeah,
Yes.
so bring it on down. Patrick.
Patrick. Where's Tim? Tim, you're supposed to be running the show here. It's out of control.
Testing. Okay, so
Patrick Goebel with PieBot.
Pi Robot. None of this
Pi Robot.
shortening his name doesn't go
Sorry
by
about that.
doesn't go by nicknames.
Ross.
So yeah, so Pi's having a little difficulty focusing on this. Okay, here we go. So as you know, the FloorBot challenge has 3 phases, of which I will complete absolutely 0 of them tonight. But this is at least...
That's not true.
At least
It hasn't fallen off the floor yet.
yeah, oh, that's right, thank you. At least it's a step in the right direction. So the FloorBot challenge has the first phase is just to get across the room and come back. The next phase is to locate an object. Third phase is to locate that object, pick it up, and bring it back. Of course, those last 2 challenges are virtually impossible, except for people at Willow Garage for the VR2. So the next best thing is we'll give it a fake object. These are called, in some circles, fiducials, in other circles, AR tags, artificial reality tags. And they're created to be essentially super recognizable even from a fairly large distance of a resolution. So they're basically just black and white square patterns, very high contrast. And they can actually be used even to, in a much smaller version, to train your robot to learn what a real object looks like by first of all focusing on the AR tag so it knows where to look. So anyway, I thought I would just write, this is a bunch of ROS nodes. It's ROS Groovy running on a little Asus laptop. It's got an Asus depth camera connected to it. And there are a number of nodes running here. One is driving the Arduino, the Arduino bridge package, and that's what's driving the motors and the encoders. There's an OpenNI node running to read the camera, both the RGB color and depth. And then I'm running a node to drive the Dynamixel servos. There's a head, pan, and tilt servo. They're AX12 Dynamixel servos. And let's see. And then I just have 2 nodes of it. The only thing I wrote myself, then there's a 4th node, which is the AR tag node that recognizes these fiducials and lets you know exactly where they are. And it's even using the depth information. I wish I could say it was Fergus's package, which is awesome, but because Fergus has written an AR Connect package to do precisely this, but I just happened to discover a new one called AR Track Alvar, and I thought I'd give it a try, and it worked right out of the box, which is virtually unheard of in robotics software, so I thought that was pretty cool. So then the only 2 things I wrote on my own were a node to track, for the head to track where the fiducial is, so you can see that it's panning and tilting, and a separate node to actually follow the fiducial driving the motor. So obviously turning left and right, and then the speed in theory picks up the further away you get. And you can see, I'm actually running this at just 320 by 240 pixel resolution to keep the video processing. There's actually sort of what's going on there. I ran this once in my living room, so that's not bad for real life. And yet you can see that even from a fair distance, it can still recognize its fiducial and track on it. It's sometimes getting a little sidetracked. If I ran it at 640 by 480 pixels, it would do a little better job from further away. But anyway, you can see how this could get you started, because you could place this on a wall across the room, and then the robot could certainly track to that point of the room and turn around and go back to where it started from. And I know Wayne is a big fan of these guys, and he's got his entire house decked out. Although, to be fair, he's put them, if I understand you put them on the ceiling, so you don't really notice them, but the robot can see them and actually navigate, because it knows exactly in 3 space where these guys are, so it can do nice triangulation and get around the house without any fancy slam or anything like that. So, that's it. Thanks.
Any questions? Okay.
What is the width, the angular width that the camera sees?
Both the Asus and the Kinect, I believe, at the RGB level are 57 degree, which is that diagonal, Fergs?
Yeah, it's okay, it's close enough.
Yeah, it's close enough, yeah. It's actually quite narrow, which you can do a fake laser scan and do SLAM with these cameras, which works not too badly, but you can't go too far away from objects and walls, because it very quickly just sees a blank field.
Any other questions?
What's SLAM?
SLAM stands for simultaneous localization and mapping. I just need to comment, Patrick, I do have to do SLAM even with my fiducials on the ceiling.
Oh, really?
Yes. Okay.
Wow.
Other questions? Nope. Okay. Let's go do the next robot. Take it over.
Actually, a comment. For purposes of the FloorBot challenge, fiduciary markings do count as objects. Okay? So none of this imaginary object. I'd like to get Loco Mo set up. So if you go ahead and continue to show the break.
Okay, one question before we move on. How many FloorBots do we have out here?
I consider mine a FloorBot.
That's a
Floorbots
FloorBot
and
table.
Tuna just showed up with a FloorBot.
Well, the big point is, does anybody need the visual markers? And I'll get those ready. If not, they'll stay in their case again, as usual. I guess that's it. Okay, so, table?
It's not really a TableBot yet. Okay. I'll just,
It'd be a little easier to see up there.
yeah. What? No, it's okay. So, most people are asking if it's a TableBot, and it's not yet because it doesn't have a sensor on the bottom so that it can sense the floor is there. So it would probably just fall off like phase 4 that he said right now. But this, I call it Ladybug. I don't really have much of a name for it. Don't know why I call it Ladybug, but the structure is just a basic robot kit that we saw from a blog, and then we used an Arduino controller and an Arduino motor shield, and then there are just 2 motors under right here, and then we have a distance sensor, because the objective of the robot is that if it sees an object, it'll see the object and avoid it by turning around. So, just like this. So if you put like your hand, it'll just turn around. And it does that for 30 seconds and then it'll stop. Or you can just take that out. And if you can't do it right now, if you put an object on its side, it won't avoid that. It'll just run into it because the distance sensor is only for the front. But yeah, so that's my robot.
Okay, we have a question back there with Alan.
It just kind of turns on its own. It doesn't really, it's just, okay.
Any other questions? Okay, who's our next victim? Oh, we go, okay.
Hello. Hi, my name is Karthik and this is Mike. We both are, we both are co-founders of AlphaLem. There is a robotics startup. And we've been doing a side project here. There is an hexapod. And while Mike is setting up, I'll be walking you through what's the hardware here. So this is, all of this is actually out of the shelf parts that we have used. Here is a Minicom component. So I think we are back again. I got some problem with the Minicom here. Anyway, so I was talking about the hardware. This is the chassis is actually from Linux Motion. If you guys have heard of it, this is Phoenix Hexabot, and I've been using the BeagleBoard XM to do all the computation. There are 2 distance sensors. I could not get my hands on 2 similar ones, so these are 2 different. One is the IRS and the rangefinder, and the other one is ultrasonic one. I'm using I2C communication channel to talk to Arduino to get the sensor readings and then to direct the servo driver to actually control the 18 servos here. Now, if you can power this up, it's the other way. It's the other way now. So this is actually programmed to actually track and we sort of thought that this is a good behavioral trait. So this will track this object and move it and back off if it's actually coming towards you. Yeah, we are moving out of room. It probably needs a space. So yeah, the sensor readings are not that clear. So the intent was actually to make mount a camera on it and then do face tracking, image processing, all that fancy stuff. So we are here. There's a work in progress still, and probably by next month we can mount a camera and do face recognition too. Probably that's it.
Very good. For those of you who don't know, hexapods are actually quite hard to do.
Yeah, appendix.
Okay.
Yeah, and the next two.
Yeah, well, yeah. Why not? Who's next?
These guys still need a minute back here. Is there anyone else?
I can do mine. Oh, you ready? Let's go. And I'll go after you.
No, that was right.
For now, this is a step. Alright, now it works. So this is going to be a firefighting robot for the Trinity firefighting contest. And so it's a holonomic drive, which I've always wanted to try. Which means it can move in all directions without ever turning or pivoting, because it has these omni wheels. And not only do they, when you turn them, do they go back and forth, but these rollers allow them to slide. So if you put them at right angles, then you can go in Cartesian coordinates around your space. So I would have all omni wheels attached, but the couplers, which are 3D printed, don't seem to be working quite yet. So, and then some other interesting. The top is a lighter, laser range finder from a Nito vacuum cleaner. So, yeah, I haven't really gotten to do anything useful with it, but it basically just spins around really fast, 10 hertz, and then takes readings out how far away an object is for 360 degrees. So. This has the potential to be used for navigating around mazes and things. So I haven't really done much with it yet, but I'll probably run like Slam or something like that on it. And then this level is a Panda board. So that this is running Ubuntu Linux. And then through serial, this is talking to multiple LiDAR, and on the lower level, the Arduino. And the Arduino is controlling all the functions like the motors and it's interfacing with the sensors. So the way it interfaces with the motors is with a Dagu 4 motor controller that I got from Robot Shop. And this is really nice. It just has a row of pins that you can control. You can use PWM on one pin to control how fast it goes and the direction on another pin. It also is pretty nice because it gives voltage, gives out voltage on how much current all the motors are taking. So you can know if one of your motors is stalling, which is really nice because then you can shut it off. That's about it. Hopefully next month I'll have it running around.
Okay, I'm going to go next, if you don't mind, Cam, okay? So it'll be really short. Okay. How many of you participated in the Club Robot this springish? Okay. This is our Club Robot, and we're working on the next phase, and actually, frankly, we're struggling a little. What we've done here is we've added a Raspberry Pi up here. We've got a LiPo battery pack that we bought, and we've also added a Wi-Fi dongle to this. And we are running something called the, I call it the Adafruit IDE, Web IDE, which allows you to develop on a laptop over there, over the Wi-Fi link. You can actually develop and run code on here. We're using Python, not because Python is the greatest language in the world, although it's not bad, but because it's the language that is usually taught to most people as an introductory programming language. So we felt that was a very good fit for what was going on here. So if the demo gods are going to work for us, all this demo does is drive forward and back. So, yeah, I need to turn the motors on. They're on. So this is not an exciting demo. What's exciting is getting all of the stuff to work. So there it goes. Whoops. It tried to turn and it twisted the sawed-off deodorant on the caster. Give it another try. So is it going to go, or is it just going to be one of those days?
The Web IDE is trying to reconnect.
Okay, one of the problems with Wi-Fi is it's can be flaky in a large environment like this. I'll tell you a little bit about what's going on here. Our biggest problem has been Wi-Fi.
It's moving.
It's moving? Cool. There we go. Okay. That was a Python program running on the Raspberry Pi, sending commands to Patrick's, it's really the H4RC's Ross Arduino bridge, talking to the Arduino. So that's all kind of working. Our biggest problem is with Wi-Fi. There's something called an access point, and we're discovering that the support for access points on Linux is not as strong as we would like. So we're trying to find the right Wi-Fi dongle and the right configurations to make it all work. Okay. So I just want to let people who are in the class know that we are working on this, and it's still a work in progress. Okay. So I'm going to shut up here. Oh, question? Okay. Got somebody coming up next. Thank you very much.
Robot, and it's by Lloyd. It has, I'm going to tell you about how many motors and what sensors there are. So there's 8 servos and 3 sensors, but there's actually only one sensor, but there's 3 sensors on each side, but it's only one big. So it took me a week to build it. My brother programmed it, and now I'll show you how it works.
Can you do it on the table?
Yeah, we'll probably go on.
Catch it before it falls off.
It kind of moves funny. You have to put your hand in front so it'll turn a little. It does a weird movement afterwards, and then turns backwards and step forward, and then goes forward again. So that's it.
All right, we're ready. Testing 1, 2, testing 1, 2.
We're not live yet.
Got power. Red? All right, very fine. Thank you very much. All right, this is my smart table, Locomo. It's basically built on a Nito XP11 and it should be coming forward here. Am I moving? Oh, there it goes. Okay, we should see the map come up here in a little bit. I'd like to consider this to be a FloorBot, although I don't know we're going to go from one end of the room to the other or not. There we go. So this is Locomo, the smart table. It's a Nito XP11 with a computer Velcroed on top, running Ubuntu and ROS. And the Nito node, thank you very much, Mike Ferguson. I've got 4 dowels and a little shallow tabletop there. Let's see, my map should catch up with me here in a minute. By the way, you got 4 minutes before the Bay Bridge closes, so just a news flash. Let's see here. I don't see my map. Oh, there it goes. Ooh, oh well. Let's keep cruising on here. I've found the best way to map is to drive in straight lines, right, Tony? Drive in straight lines, right? He's not paying any attention. All right, Tim, I'm coming at you there. There's Locomo. I'm navigating to the wall there. Okay, so we can see the wall approaching. And it'll take a minute here for the map to update. We're mapping a very vast expanse here at the HBRC. 11th annual HBRC Challenge Phase 2. Yes, Jared? That's a good question. Let me check. I'm totally delocalized too here. Let me get this map going here. This is going to end up with a question for all of you ROS experts out there. So let's see where we are. We're in Mountain View, and we're in the Crusher Lab or something like that. And here was the original hallway. Oopsie, let's go up. So here's the original hallway here. It looks pretty bad. And then we took a left turn and drove over there. Regardless, I don't want to take a lot of time here. I don't think I've taken too much already. But I've got some Nito, cheat sheet here for attaching ROS to the Nito that I'll put on the mailing list. So right now, let me just struggle ahead here, and I'm going to copy this nifty map saver. Bear with me. Fascinating, huh? Okay, so actually while we're waiting, let's see if we can make the map. Well, actually I'm saving my map now, so I shouldn't mess with it. Hey, do you kill G mapping before you run 2D nav? All right. Saving map, that's what we're doing. Waiting for the map. Do I need to drive it back to the original location? Well, I've already got the map. There it is. Well, I'm saving the map, and I'm still waiting for the map. Okay, bear with me. No, it's coming. It's coming. And I'm going to do something here. I'm going to go to Ubuntu's file system. 2, 3, 4. Oh, the Bay Bridge is just about closed now, folks. In case you didn't get the news release. And This is painful. Who's next on the agenda here? Oh, all right, all right. Oh, there's my map's done. How about that, huh? All right. So here comes map, PGM, and the map YAML. I'm gonna cut that and bring it over here and there. And Nito robot node. Thank you very much, Mike Ferguson. Maps. And let's paste it in there. Replace, replace. Now kill G mapping. Killing G mapping. ROS is fun if you haven't gotten into this yet. It's really a blast. Okay, here comes my 2D nav. I got to get my Nito cheat sheet here. 2, 3, Control C, and paste. Boom. Okay, so now, you'll see I'm having trouble localizing here. Receiving map, bear with me. Okay, now you're really going to see something fascinating, folks. This is what you came for. 2D nav, and I'm pointing and pressing and dragging and releasing. Is the robot doing anything? Let's try. I really know what I'm doing here. Polygon. This is the one that got me last time. Anybody home? Okay. It's trying to navigate. It can't find, and it's aborting after all because of recovery. But someone will talk to some of you ROS guys back there later. Right now I'm just going to drive my humble robot table back to its origin. And so this is Loco-Mo, folks, the smart table. Thank you very much.
Okay, Roman.
Sorry, we got wire roll.
Okay, we're going to wire Rohan and he'll be up here in a minute.
Hello? So, I have a TableBot here. It's a TableBot clone, and it's using a Hokoyu LiDAR on it, and so I'm going to try and do FloorBot challenge phase 1, drive to one side of the room and back. So yeah, this is my little mini room. Okay, so that's one side, and okay, back, and I'm going to try like seeing if the localization, it'll avoid me, and it sees me. And it figured out that it's where it wants to be. Uh-oh, it's recovering. Okay, so it successfully avoided the box now. So this is using ROS's navigation system, and it with the Hokoyu LiDAR, and It's running, right now it's just running G mapping. Oh, it's lost. Yeah, so right now it's just running G mapping, and it's, so it's, with G mapping it's not the best to just use nav goals because then it gets lost a lot. So, yeah, but that was just a little demo.
Did you previously map this space, or were you doing it?
No, this
right
was
there?
actually doing SLAM right now. So it wasn't very, that's why it was like really erratic.
Oh, here we go. Okay. Hello. This is the new Lego robot release, Lego Mindstorm's EV3, which is awesome, and I love it, even though I've only had it for a very short amount of time. So this is pretty much the first set you build out of a little instruction booklet that comes with the education set. Because that started shipping on August 1st, and regular retail doesn't ship until like September 1st, so yeah. The EV3 has a few differences from the regular old NXT. The sensors are new. There's some new sensors. Well, the touch sensor got sort of re-engineered, so now you can slide things over it more easily, and we have this color sensor that comes with the kit as well. And we have a gyro, which is awesome. And it seems to work pretty well, although I haven't done much with it yet. And also, all the mounts have a little axle hole in them now, you can see that. So they're easier to mount. And the retail version has an IR seeker and a blue beacon here, but the educational version just has another ultrasonic sensor. So, and there are some new motors too. There are two of them that look pretty similar to the old ones, if you can see them. They're kind of buried in here. But the third motor that comes with the set is this new medium tiny motor, which is very handy for many things. And there are now 4 motor ports, which is very handy. Ooh. And we have this ball caster. So gone is the age of all these hours and hours spent trying to find a good caster wheel. Now it just has a convenient little ball caster, which I love. And there's a new brick too. It natively runs Linux, which is ooh.
You have to start doing it actually.
Yeah, it takes ages. But it has a lot better in-brick programming, which is like the only thing I've done yet because I haven't had very much time to work with it. And if you want, I can give you the details on the microprocessor. Some compatibility. All the NXT sensors will work on the EV3, but none of the EV3 sensors will work on the NXT. So, but the motors are all cross-compatible with everything. And so the educational version comes with this ultrasonic sensor and the rechargeable battery too. So instead of taking apart your robot to change the batteries, you just have to snake a wire through into the little recharge port, which is going to be great. And you can get it as of August 1st. And retail, you will be able to get it on September 1st. It will start shipping. And it has this IR seeker and some sort of IR beacon. And that's about it. I have a few little demo programs here. This one, it goes until the ultrasonic sensor senses something, and then it stops in its tracks, and then it's done. Oh, the robot's name is the One Robot Angry Mob because I gutted one of the Lord of the Rings sets and I got a pitchfork and a torch. So it has a torch and a pitchfork, so it's the One Robot Angry Mob. So, yeah, it stops on the tracks. And we have another one that uses the gyro to decide when it should finish turning. So it's supposed to turn 45 degrees, but it actually turns a little bit more like 60, but yeah. And that's it.
Shiloh, over here. I have a quick question. Are there any differences between the battery packs on the educational and the retail?
The retail doesn't come with the rechargeable pack. You have to use the regular batteries.
Yeah, so because her mic went off. The retail does not have the rechargeable battery pack, just so you folks know. I knew the answer to that question. I was just going to remind her. Okay, you ready, Tuna? Okay, we wire up Tuna here.
Okay, we've got another FloorBot coming up.
Okay, so this is connected to my laptop. It's using the video image from the tablet that's broadcast on the laptop, so you can see the video that's captured from this camera or there, and the video that's captured from the camera of the laptop on the tablet. And in addition to this, I can also drive it with my phone. So by tilting the phone, I'd use the accelerometer of the phone to figure out what direction or where to turn or to go forward or backward. I have a very simple user interface. So I touch the screen and then I can just move it. And depending on the motion of the phone, it will just turn. So let me explain a little bit of the technology behind it. I actually just built this today. But basically, it has a power board here to drive the motors with a bunch of MOSFETs. Then there's a speed controller behind it. All of this is connected to an Arduino. And the Arduino is connected to a BeagleBone Black, which runs Ubuntu with an Apache web server. And the interesting part of this is that I'm trying to move robotics to use open web standards, such as HTML5, JavaScript, and WebSockets. It turns out that a lot of the features that you find in ROS, such as topics or PubSub or RPC calls, actually come already built into your browser. So you actually don't have to install very complicated software. You can just use your browser, and in this case I'm just using Chrome, both on the laptop and on the tablet, to get the same functionality. So the BeagleBone runs an Apache web server, and I have some JavaScript code that uses HTML5 to capture the video from the tablet and broadcast it to the laptop. And I'm using WebSockets to connect the cell phone via Wi-Fi dongle, which is connected to the USB hub here, to the web server the same way. And it uses just the WebSocket protocol to execute RPCs between the web server here and the cell phone. And you can sign up for topics just like you would do in ROS, for example, but it's very easy because you can just do it in JavaScript, and it's already supported by the HTML5 standards. Yeah, so that's about it.
Hello? Okay. Hello?
As you can probably tell, it's totally working, right? Yeah.
Okay, so my name is Maxime, and here I have a Roomba 500, x86 Acer Chromebook. We actually have two of them. One is hooked up to the robot, well, will be, and the other one is the desktop. And so, oh yeah, so this Chromebook, the first thing I did was I installed Ubuntu, which is Chromebook, Chromebook version of, Chromebook version for Ubuntu. And then once I did that, I just installed ROS Groovy. And then I used this ROS by example book. To help me with doing the networking between the two robots, and also RViz. So we got a fake TurtleBot, and we controlled it with the arrow keys on the Chromebook. So then we tried hooking this Roomba 500 to the robot, and
So that's actually where we pretty much stopped, because it turns out that Ubuntu, which is a version of Ubuntu running on a Chromebook, does not support USB to serial module or the kernel driver. So we are not able to, short of compiling our own kernel modules, we're not able to connect our Roomba. So we're kind of stuck. And if somebody has any ideas of how we proceed, do we go back to normal, netbooks, but I guess we kind of at the point where we don't know what to do. It's pretty much we have these two Chromebooks that almost like the Linux laptops, but because of this limit with the module, we kind of don't know what to do with them. So we're at Google here. Google, maybe you can help us. All right, that's.
I have a question.
Yes.
So, I know this sounds to many of you all like a really stupid question. I'm sure it is. But if you don't know the answer to a question, then a question's a good question. What's a fake TurtleBot? Is that a virtual TurtleBot?
Yeah.
Virtual like on your. Okay, got it. Thanks.
All right. Thank you.
Do we have any more robots to show? That's good. Yeah, he's got it. He said no.
What, 60 seconds and counting, okay. Hi, my name's Mark, his name's Maxwell. His functionality hasn't changed a whole lot in the last couple of months. Right now he's set up with basic face detection. So when he picks me up, he lights up his eyes and opens his mouth and say, "Oh, I see somebody." And then he tracks me. What I've changed is, he used to be running in there's a small PC running in his torso, which is running Windows XP. Remember Windows XP? That used to run his program through that. I decided to change away from Windows XP to Linux, which is that other small black box here on the side here, this little guy. So he's running under Linux now. He's the program that does the operation, the face detection, connecting to the webcam, running the eyeballs and the servo control is all written in Java. It was a bit of learning to figure out how to get Java and OpenCV and all that stuff running in Linux, because I'm not really a Linux person. I'm somewhat more of a Linux person now. Yeah, so these all pieces, this is a halfway jump, so there's another PC which I leapt to. The reason for this pursuit is both these PCs do the face detection fine, but I found out when he's been set up in public looking at a sidewalk, if you're walking by him on the sidewalk, he doesn't pick up the face fast enough. If you just walk by and glance at him, he doesn't have quite enough processing to grab that and figure out that you just looked at him. So right now with Linux, which ironically a 1 gigahertz processor in Linux does the face detection faster than my 1.6 gigahertz Windows machine. But it's still only about 10 frames a second, about 100 milliseconds average, but sometimes it's a little bit faster, sometimes a little bit slower. I figured that I have to be always faster than 100 milliseconds roughly to be able to capture that quick walk by glance and look away again. So the next PC, which is still at home, goes beyond this, has an extra graphics processor, and I've gotten to 15 frames with that one. So this is my halfway along mess, but actually does run. And that's it. Thanks.
Thank you very much. Okay, are there any more robots? Going once, twice? Do you have a demo? You told me you didn't have a demo, so. While he's relocating up front, the talks that we have presented at this meeting are basically volunteer talks, and our program chair, Alan Fetterman, who is somewhere around here, I'm not picking him out. There's Alan. If you have any proposed talks that you might want to give at this club, please see Alan. He's the person that schedules the talks. Okay. So do we have anything scheduled for next? Is that a yes or no? I can't hear you over the noise. Okay. Yeah. And anything for November? So. Yeah. So we still need one for November. So please help us find presentations. Okay. We're doing the usual setup here. Yes?
Okay, so those who don't know me, Seal Craig, I'm with Western Region Robotics Forum. We put on a high school robotics competition called Cal Games. It's coming up October 4th and 5th at the Sunnyvale High School, but it is the Fremont High School in Sunnyvale, but it's not in Fremont, it's in Sunnyvale. You got that? Anyway, I'm still looking for a few more judges, but I was thinking if any of the ClubBots or FloorBots wanted to come and demo in a little area at the high school. We get usually about 3,000 or 4,000 people, public, 36 teams. We got a team driving actually down from Idaho. So we have quite a few robots there. They're a lot bigger than these, I have to admit. About 120 pounds typically, 100 pounds, 5 feet high, 2 by 2.5, something like that. But I think it would be good for them to see robots who are not out of a first, which is their model. Okay? So if you're interested, write me, come and see me, something like that. But I think having some of the FloorBots and the ClubBots, FloorBots and tabletop bots from Homebrew would be kind of cool, because we have a lot of judges from Homebrew.
Very good. David reminded me of something that I forgot to mention earlier, so I'm going to hand it over.
So, how many people were here last month for Ted Larson's 3D printer presentation? Bunch of folks? Okay, yeah. Anyway, Ted has been working with a FlashForge Creator 3D printer, which is kind of a MakerBot clone. MakerBot's kind of moved on to the X2, but there was a lot of cool things about their previous one, and the Creator is more of a clone of that, although they've made some changes. Ted is bringing one of those up. And several of us are looking at actually kind of drafting behind Ted's work and getting a bunch of those and cloning all the tune-ups that he's doing to that. So anyway, I'd like to get anybody that is interested in participating in a project like that to just, let's cluster maybe over there during random access. The idea would be to get a bunch of identical 3D printers, starting with that as a base, and adding our own tune-ups. So at least we all have identical machines, even if we've all hacked on them. So we'll just meet over there when we go to random access. That's it.
What's the price of the printer? Did you mention that?
It's like $1,200 for the base printer. And I think Ted has probably got another $300 or $400 worth of tune-ups in it. So it'd be under $2,000, but that's kind of where we're headed. So if you're all excited about joining the 3D printer lifestyle, that's the way. This would be our replacement for ours. So anyway, okay, ready? Yeah. Okay, so take it away, demo.
Like that? Okay, yeah, hi. Alright, so technically, the robot should have been moving around by all the data I was looking at a few minutes ago. It was telling me it was moving around, it's not moving around. So instead, I'm just going to show something really quick here that I did right after the last meeting. This is kind of, I don't know, in some ways trivial, in others kind of pretty cool hack to the Nito laser controller. For those of you who are using a Nito and do not have a Nito board and you're just using the laser, one of the things you have to do is you have to control the speed of the laser so that you actually get accurate data out of it. I've made a fix for that, and now, in addition to the /scan topic, I made a mod so that it also publishes an RPMs topic. So you can just subscribe to that, and you can get, and from that you can, the data you're seeing here, so this is a little listener node that I wrote, and it's listening to the RPMs topic, and it's tweaking the laser RPMs. It's PWMing the laser under software control, which is not nearly as good as hardware, plugging it right into a Nito logic board, but if all you've got is the laser, that's that. So hopefully next time I can show you a moving robot. But this is being committed to the CWRU XV11 laser driver package. It's on my GitHub. I sent them a pull request, and Eric Prokhorov took it. So this is out there in the wild now.
Very good. It occurs to me that a number of people are new here and don't know that ROS stands for Robot Operating System. So I just thought if you didn't know, now you know. It is a set of communication tools and packages that run on top of Linux these days. Okay. Are there any further questions? Okay, with that, we're going to take a wrap on the organized portion of the meeting. We're going to go into random access. I hope everybody had a good time, and hopefully you'll come next time. So thank you very much.